Hello.
Hi Shenyun,
Hi. Hi. Hello. Hi. How are you? So
how are
hope
you?
everything has been all right.
It's been okay-ish.
Okay. Okay. All
How
right.
have you been?
So yeah. Apologies. I think on Friday I probably already had something scheduled. Okay.
Oh,
So
okay.
yeah.
You'll be able to make it.
Usually my schedule in a day is pretty tight. So yeah. So yeah.
All right.
But on Wednesday, occasionally that's fine.
Okay.
So let's start. Okay. All right.
Sorry. Thank you.
And if Herman can come online, that's fine. Okay, that's fine too. On Friday. I mean, if you want to have another sync with him. Okay.
Okay.
Yeah.
Okay.
All right.
Okay.
So maybe we can start and yeah, please update and share what the
Discuss.
current state is. Yeah. Thanks.
Oh, okay. So
Okay.
from the last time, we wanted to sort of write the code, or
Right.
at
Right.
least
Right.
start the code. Sorry,
Right.
my screen is
And
frozen.
what did
Let me
you
just.
what did you decide to use?
I had to end up using Python.
Okay,
It
Python.
was
That's
sort
good.
of the most
Okay.
straightforward.
Yeah. Sure.
MATLAB was working, but a lot of them were like third-party libraries, and
Okay.
I'm usually skeptical with
Okay.
like
Okay.
libraries.
Sure.
Yeah. Now what? My screen is frozen. I don't know if you can see it. I can't.
Okay.
Can you?
Maybe we share again if it moves.
I can't even do anything. Come on.
Okay. Okay. I see. I assume you're working off
But can
the
you see it though?
tablet.
Yeah.
Yeah.
It's literally frozen. Like
Okay. Okay. All right.
I can.
That's fine. Maybe then maybe okay. Usually try to stop the
Um,
program, restart or restart the computer helps. but
um,
but
yeah,
maybe
but
you can
I don't want it.
update just orally first. Like what have
So
you been?
basically, I try to use Python
Right.
to what's the word, to create nodes. So there's a function in Python that allows you to create linked libraries. I mean
Okay.
linked nodes, right? Where you can create nodes and then sort of link the nodes with one another, or should I say link node A to node B, right?
Okay.
With sort of a track of what the head is and where should I say where they are in the chain. So think
Okay.
about a linear, like a set of linear blocks. All right, there you have
Okay.
node
Okay.
A, node B, link to node C, but now each node has its own data set in terms of I'm actually shocked that I can't do anything on this computer. Each node has
Okay.
its own data set
Okay. Okay.
in terms of P1, P2, P3.
I see.
So
When you say they're linked, what do you mean? I mean, does it mean that they can send message to each other, or they can just call each
yes,
other's
they
function,
can.
or?
The idea is the next node has information about the previous node,
Okay. Okay.
if that makes
Uh-huh.
sense.
All right.
All right.
Okay.
And the goal is to sort of just create this web of devices with each of them having their own what do you call it, predefined data set in terms of
Okay.
maybe the
I see.
ID, the
I see.
message, the payload. And
Okay.
then once that is set properly, then the manipulation, or should I say the data process can now start. Okay, I'm
Okay.
just
I
trying to
see.
connect to maybe my laptop will be
Okay. All
better
right.
suited for this.
Mm-hmm.
Because geez, I don't know. Um Sorry, just give me a moment and then I'll maybe restart my computer.
Okay. Sure.
But at the moment, yeah, it's sort of a bit tricky to execute when it gets complicated. I get errors. That's why I have like multiple
Uh-huh.
code
Okay.
versions.
All right.
Let me just show you.
Okay. Uh, I guess let me just ask a few questions to clarify. Okay.
Okay.
So for the first thing is, do the nodes can they do like like any to any communication? Meaning
Sorry, I
that,
didn't get that last part. Any to
okay,
any.
are the nodes able to do any-to-any communication? Meaning that that's you have like say 10 nodes, right?
Yeah.
Can you write logic? So node A can communicate with node B, exchange message, and like sorry, node 1 can to node 2, and maybe
Yeah.
node 1 can also communicate with node 3, and node 5 can communicate to node 7. Is that something that's possible?
So in theory, and use in theory to be more very generous. In theory, node sorry, this
Okay, yeah.
in theory I should be able to choose what's going on here.
Okay, maybe just close off one of the yeah, one of the microphone.
Jeez, why is it frozen? Okay, I'm just gonna restart that.
Okay, sure.
Sorry, I'm back. So in theory, you should be able to do that.
Okay, that's good.
When I say do that now, it's supposed to be able to, like node 1 should be able to communicate to node 2. But the way I sort of picture it, it sounds like the Python environment, or should I say this library, has its own internal management system that allows it to sort of keep the information in a sort of cached format, if that makes sense.
Okay, sure. Yeah, it's in memory, right? It's in memory.
It's in memory, yeah, exactly.
Okay.
So
yeah,
if I wanted
sure.
to call a function, call,
Okay.
Call something basically from the chain, I should be able to get it.
Okay.
Sort of struggling to sort of
right.
isolate the core data or data points.
Okay. So okay, so let me put it in my understanding. Okay. From my understanding, what you have is, and let me also map this to what has been done in the VAST implementation, is that what you just described is an network communication abstraction. Okay.
Yes.
Meaning that you are able to write logic for individual nodes that could be simulated, or
Yes.
or run within processes. I don't know, maybe a single or multiple processes, and then they can communicate with each other. And this can be done through an abstraction. Okay. And the abstraction usually is simply you can send something from A to B, right? And likewise, you can process the message from that's being sent from another node, right?
Yeah, precisely.
Okay.
Yes.
So that's fine. Okay, that's fine. Okay, so yeah, by all means set that up. Okay. But then I think the next step um, is that you will probably need at least 2 more layers on top of that. Okay. And what I mean 2 more layers, okay, yeah. So Herman, you want to? Oh, sorry. The Victor, you want to show some of the things you've done already?
Yeah. So I was trying to. So in theory, if I say, can you see this?
Yes, I can see that.
So in theory, I mean, this is the process you have. This is what it looks like. So you have the head, which is the root. So maybe P1, and go across the nodes. Each is a record kept until the last node, which points to nothing now. So in this case, I try to our case, which is P1. Let's call it position, for example, and then P1 has, or P1 should have this data structure, the ID section, the channel, and maybe the payload section, which would be actually channel and message. But anyways, but the idea is this should now be defined.
Sorry, Victor, I'm not able to hear your voice.
Can you hear me now?
Yes, I can hear now. Yeah.
So yeah, I was trying to open this now. Yeah, this was the first one. It sort of got complicated. I started getting errors, so I just had to simplify it. Notice, I don't know if you can see this is too small. So first, there's a single node, the class, like a function to define code, right? And then you
Okay.
have so this is pretty standard in terms of Python libraries now. I didn't like do anything super special. A bit of tweak here and there. But the
Okay.
idea is this is now the insertion method or function for the linked list. So after you've created a node, this is them. So if you look at this, there's a bit of current next. So that's like node 1 to node 2. Think of it as the arrow in between. And then this is just to print the results.
I see. Okay. All right. Okay.
So, I mean, when I say print head now, for example, I'm supposed to get something like here. I'm supposed to get something
Okay.
is
Yes.
like
Yeah. Victor, yes, this is understandable. Yeah. What you have done here is a simple linked list data structure that basically
Yes.
chains up a number of nodes. Okay. Yeah, but I think this is not fully what I think what we would be expecting from a network layer.
Okay.
Yeah, because this is simply a way to just have a bunch of nodes, and you can maybe reference them. But likewise, I think you can equally well use some kind of array, to chain them. But the more important thing is, I guess, from a sort of a current to future implementation perspective, is that what you want is actually be able to implement some kind of logic, okay, that potentially can work whether you are in a simulated environment or an actual physical environment. You see, you don't want to just write something that can work in a simulator, okay? But then when you want to deploy onto the actual physical environment, and you literally have to rewrite everything. Although that is good for learning, okay? But I would say, since we've outdone that before, okay. I mean, I can, for now, just save you from, this trial and error.
Okay.
And I can also share that, I mean, the VAST library, it was actually written from the start to basically separate the logic from the network layer in the, I think both the C++ version and also the JavaScript version.
Okay.
You see, does that make sense?
Yes.
The reason why I see this approach, the linked-list approach, has an issue is that you are essentially putting all the data of, let's say, whether it's a 10 nodes or 100 nodes into a single data structure.
Yeah.
Okay, this will work when you're running simulations. However, this will not work if you are actually doing, or I mean, at least if you're actually running, like in 100 devices or 100 sensors.
Okay.
You see?
What you mean?
Okay. Because, and besides, I don't think you even have to have a linked list. If all you want is just, a data structure that keeps a bunch of nodes, you could just use an array to do that, right?
Okay. Yeah.
Okay, linked list is not really needed here, actually. Okay.
Yeah.
I mean, if you want to just like, let's say you want to use some logic and process each node, you could very easily do that with a simple loop, right? And then just, go through all the nodes within an array and then execute the logic that that's contained within them. Okay, you see what I'm saying?
I see what you mean. Yeah.
Yeah. Okay.
Right.
So I think it's perfectly fine, to write something in Python or any other language. It's not the main issue, but I do see an issue of okay, that I think regardless of the language, there are some certain structures that sort of speak, okay, or how let's say data and logic are being maintained or kept, right, or executed. That should be maybe more or less common.
Okay.
Okay. So I guess what I like to see, sort of as a next step, um, I think that the important thing right now maybe is for you to implement, the spatial pub/sub part, the spatial pub/sub logic first. Okay, and without worrying too much about the about how the underlying things are communicated. Okay. And I mean, right now the linked list, it works. Okay. I mean, it will also work. Okay. That is not to say it's not. It's just that I don't think a linked list is necessary. Okay. You see, I'm pretty. I'm not that familiar with Python, but I assume there are some data structure like array, right?
Yes. So
right? There probably
I
should be
see
some
what
kind
you
of
mean.
array. Yeah.
So that's where the P1, for example, is sort of replaced with the array.
Right. I think you can just use a simple array to keep track of all the nodes, and that's fine. That should be fine. Okay. And the important thing is to write for a single node, what the logic should be. Okay. I mean, you should assume, you have to assume something, which is whenever you're writing a logic, okay, you can only rely on local data structure. Okay, do you see what I'm saying?
Good. So at the moment, the idea is to not focus on all the layers at once, just focus on the logic for now.
Yes, I think yes. Starting from the logic will maybe, well, at the very minimum, you will be thinking about how to implement your pseudocode, right, or the code that's in your paper onto an actual implementation, right? I think that is like more important for now. Okay. Does that make sense?
Yes.
Yeah. I mean, you can think of this way. Okay. Regardless of whether each node is run in a simulated environment like the one you're doing, or on an actual physical device, right?
Yeah.
The best would probably be they are running the same logic. You see?
Okay.
Right? Do you agree?
Yeah.
Yeah, because that means, you can, maybe just run in a simulated manner, let's say 100 nodes, right? Or even 1,000, right?
Yeah.
And you can verify and validate that it works correctly, right? It passed the simulated test, and all the logic works as expected, right? And so when you deploy that into some kind of physical environment, it will probably work, more or less, hopefully, okay? Or at least you don't have to troubleshoot and debug all the various crazy issues, right? At least you can make sure the logic is correct. And then maybe you can debug whether there's some network layer issue, right? Whether there's some communication issues, right? You see?
Okay.
But throughout this whole process, you want to keep the logic the same.
Okay.
Okay, and that it can be moved from and execute within both a simulated environment and also a real physical environment. Okay, that makes sense.
Yeah.
Okay, so when I talk about each node can only access local data structure, it means that do not assume that it knows any global data.
Okay.
Okay, but the linked list you're
Okay.
creating now, it's actually a kind of a global data. You see?
Yeah.
Agree?
Yeah, you're right. It's a global data, exactly.
Right. You don't want that. Okay, you don't want that. At least you don't want that to be accessible to each node's logic.
Okay.
Okay, it can be accessible for the simulator, which is fine. But when you're writing the logic for each node, you should make sure that it's as self-contained as possible.
Okay.
That makes sense?
I see what you mean. Yeah.
Okay. All right, good. All right. So I hope to clarify these few points because I mean these are kind of like the high level architectural view, right? And concepts that you should keep in mind when you are doing, any kind of implementation.
Yeah.
Okay.
Yeah. I think it's I didn't look at it as an API.
Okay.
The in between.
Yeah.
It's supposed to be in between and not necessarily supposed to be a block.
Right. Okay. Yes. So yeah, you can look at it from the point of view, yeah, as an API as well. Okay. So I guess what I would like to see.
Will you be available tomorrow?
Tomorrow, yes. I think I will sync again tomorrow as well. Yes.
All right.
Okay. So I guess what I'd like to see is if you can maybe just write, the PubSub logic first.
Okay.
Okay. And then every time when you need to either get message or send message, just write a simple, interface for that purpose for now. Okay. Which means that, in the future, it can be implemented either, through a simulator or an actual physical communication channel. You see, like over TCP or UDP.
So it
Okay.
can just be like a placeholder sort of function.
Yes, a placeholder, exactly.
Okay.
And you can, if you want some reference, you can look at the vast C++ or JavaScript code, because that's how actually it's been designed. There is a network layer abstraction, okay, which is at the very high level. It's just, you connect to another node, given its IP and port, for example, you can send, and then you can process message sort of from within your local message queue for any of the incoming message that's sent by other nodes.
So
Does that make sense?
yeah. So basically the logic, okay, I think I'm not focus on the icon, but for example, in a publisher mode, a network request would be, I'm sorry, let me say publisher, where, for example, it wants to sort of just send a message, and it can be like a placeholder where it just handles the network part of that. And
Exactly.
publish.
I mean, for now, actually,
For now.
I would recommend assume a placeholder for the actual network communication, okay? And just write the logic first. And also even, okay, you want to separate between the PubSub logic and also the underlying, the connectivity logic, which is what, the WAN network supposedly should provide, like who are the neighbors, for example, right? If you are writing the logic for a matcher, you see? Okay. And but I mean, if you feel that's too complicated, it's fine. You can just write both. I mean, just write however you see fit, and we can try to separate them.
Oh, that's way simpler. I mean, it all breaks down the process, which is
Exactly. So, I mean, if you can understand, there are probably 3 layers, right? On the bottom is the network layer. That's doing node-to-node communication. On top of that, there is the P2P layer, okay, the peer-to-peer layer, which is, you can think of it as an overlay layer, right? It forms an overlay network with nearby nodes, right? You can discover your neighbors, who your neighbors are, right? And maybe communicate with them. And then on top of that is the PubSub layer, right? And on top of that is the application. Okay, and you are writing, everything that is below the PubSub layer. Does that make sense? Okay, all right. So I guess, is it clear what's
Yes.
kind of what I'd like to see before our next
Yes.
meeting?
Yes, definitely.
Okay.
I actually do remember the VAS. When I think of the VAS code now, I actually remember it. I think I should have looked at that as well. There's a lot of logic there in terms of the nodes. I remember seeing a lot of logic,
Right.
like simple logic.
Right. Exactly. So I mean, you can, if you like, you can take a reference of that. But I mean, just write whatever feels most natural and comfortable to you at this point. Okay. And once you have the logic done, there's also the benefit of it's actually a test case for your underlying layers. You see?
Yeah.
Because once you have the logic, right, and then you can actually use that to verify whether the expected communication, well, but anyway, essentially, I think just they can be, the logic is basically test cases for whatever functions you're implementing at the layer below that. Okay. So it's also a form of test-driven development. Okay, meaning writing test case first, and then verify, validate your other functionalities. Okay, is that okay, Victoria?
Yeah.
So I guess any questions or anything you feel stuck or confused or like to clarify?
No, it makes sense. I think I made my point. Right from the top to the bottom.
Yes. Actually, yes. Yeah. Okay.
Thanks, Janine.
All right.
helpful.
So hope that helps, and just like to see the first version of the pseudocode for the logic. Okay, maybe by tomorrow. Okay.
Definitely.
Yeah. All right. Okay. So good luck, and I guess I'll talk to you tomorrow then. Okay.
Tomorrow, yes.
Okay.
Tomorrow,
All right.
tomorrow.
Okay. So thanks and take care. Yeah.
You too.
Okay. Yeah. Take care. Yeah. Bye bye. Bye bye.